Welcome. For the next hour, we're going to explore the ocean together, the vast, mysterious depths that cover most of our planet. There's no rush, nowhere to be, just calm facts about the deep blue world beneath the waves. Let yourself relax. Let the words wash over you like gentle waves. Let's begin our journey into the blue. The ocean covers approximately 71% of Earth's surface. That's about 139 million square miles of water. If you were to look at our planet from space, you'd see that we live on a blue marble, dominated not by land, but by ocean. In many ways, Earth might be better named ocean rather than Earth. We are, all of us, inhabitants of a water world. Despite this vast expanse of water surrounding us, we've explored less than 5% of the world's oceans. Despite all our technology, despite centuries of sailing and decades of deep-sea exploration, the vast majority of the ocean remains unknown to us. There are mountain ranges down there we've never seen, creatures we've never encountered, entire ecosystems operating in complete darkness, untouched by human eyes. The ocean keeps its secrets well. Part of why the ocean remains so mysterious is its sheer depth. The deepest part of the ocean is the Mariana Trench in the Pacific. It reaches down nearly 7 miles below the surface. That's 36,000 feet. If you placed Mount Everest at the bottom of the Mariana Trench, its peak would still be more than a mile underwater. The pressure down there is over 1,000 times what we experience at sea level. It's a place of extremes, of darkness, of crushing weight. And yet, even in that deepest place, life exists. In 1960, 2 men descended to the bottom of the Mariana Trench in a submersible called the Trieste. At the deepest point, in the Challenger Deep, they saw a flatfish and some shrimp. Life finding a way even in the most hostile environment imaginable. Since then, scientists have discovered entire communities of creatures living in the deepest parts of the ocean, adapted to conditions that would instantly kill most life on Earth. Throughout all this water, throughout all this depth, the ocean holds treasures we can't quite reach. The ocean contains about 20 million tons of gold. It's dissolved in seawater, spread throughout the vast volume of the ocean. The concentration is incredibly low, only about 13 billionths of a gram per liter of seawater. It would cost far more to extract it than the gold would be worth. So it remains there, glinting invisibly in the water, beyond our reach, a fortune we can see but never spend. The ocean also contains virtually every element found on Earth: sodium, chloride, magnesium, sulfur, calcium, potassium, all dissolved in various concentrations. Scientists estimate that if all the salt in the ocean were removed and spread evenly over the land, it would form a layer about 500 feet thick. That's approximately the height of a 40-story building. The ocean is not just water, it's a complex solution, a chemical soup that makes life possible. Hidden beneath all this water is a landscape as dramatic as anything on land. The longest mountain range on Earth is underwater. The mid-ocean ridge system stretches for over 40,000 miles, winding through all the major ocean basins like the seam on a baseball. It's where tectonic plates are slowly pulling apart and new ocean floor is being created. Volcanic activity along these ridges helps shape our planet, mostly unseen by human eyes. Mountains are being born down there, right now, in the darkness. These underwater mountains are not barren. Hydrothermal vents along the mid-ocean ridges spew superheated water rich in minerals. The water can reach temperatures of over 700 degrees Fahrenheit, and around these vents, entire ecosystems thrive. Giant tube worms, some reaching lengths of 8 feet, cluster around the vents. Blind shrimp, white crabs, and strange fish make their homes in this boiling, mineral-rich water. They survive not on energy from the sun, but on chemical energy from the earth itself. It's a form of life completely independent of photosynthesis, a second genesis. But the ocean isn't just a mysterious landscape to explore. It's essential to our survival in ways we often forget. The ocean produces at least 50% of the planet's oxygen. Tiny marine plants called phytoplankton drift near the surface, using photosynthesis just like plants on land. These microscopic organisms, invisible to the naked eye, are responsible for every other breath you take. The ocean isn't just where life began, it's what keeps us alive. With every breath, thank the ocean. These phytoplankton form the base of the ocean's food web. Zooplankton eat the phytoplankton. Small fish eat the zooplankton. Larger fish eat the small fish, and so on, up the chain. Everything in the ocean ultimately depends on these tiny drifting plants. A single drop of seawater can contain millions of these organisms, each one capturing sunlight, producing oxygen, supporting the vast web of life above and below them. They are the invisible foundation of the visible world. In this world of water, the rules are different from what we know on land. Sound travels about 4 times faster in water than in air. Whales use this to their advantage, communicating across vast distances. A whale's song can travel for hundreds, even thousands of miles through the ocean. In the quiet depths, sound becomes the primary sense, more important than sight. The ocean is full of conversations we can barely imagine, songs being sung across entire ocean basins, messages traveling through the deep sound channel where temperature and pressure create perfect conditions for sound to travel enormous distances. The blue whale, the largest animal to ever exist on Earth, produces sounds that can reach 188 decibels. That's louder than a jet engine. These low-frequency calls can travel across entire oceans. Before the age of motor ships, blue whales may have been able to communicate across thousands of miles of open ocean. Now, with the constant noise of shipping traffic, their communication range has been dramatically reduced. The ocean has gotten louder, and the whales have gotten quieter to us. The ocean also holds our history in ways we're only beginning to understand. There are more historic artifacts underwater than in all the world's museums combined. Thousands of years of human history rest on the ocean floor. Shipwrecks from every era, lost cities, ancient trade goods, pieces of civilizations that thought they'd be remembered differently. The ocean is the world's largest museum, and most of it remains uncatalogued. Every storm, every navigation error, every act of war or piracy has left its mark on the ocean floor. It's estimated that there are over 3 million shipwrecks on the ocean floor. That's 3 million stories, 3 million moments when the sea won. Some are ancient Roman vessels, their amphoras still intact after 2,000 years underwater. Some are Spanish galleons, heavy with gold and silver from the New World. Some are modern ships, submarines, aircraft. The ocean takes them all, preserves them in the cold, dark water, and keeps them, a library of loss. Moving through all this history, through all this depth, the ocean is never still. The ocean has its own rivers. These are currents of water moving through water, created by differences in temperature and salinity. The Gulf Stream, for instance, is like a river within the Atlantic Ocean, moving warm water from the tropics toward the North Atlantic. It's about 40 miles wide and can move at speeds up to 4 miles per hour, carrying more water than all the rivers on land combined. Without the Gulf Stream, Britain and Northern Europe would be as cold as Labrador in Canada. These ocean currents are part of a global conveyor belt that moves water around the planet. Warm surface water flows toward the poles, cools and sinks, then flows back toward the equator as deep cold water. This process takes about 1,000 years to complete one full cycle. Water currently in the deep Pacific may have last seen the surface when the Vikings were exploring North America. The ocean has a long memory, measured in centuries and millennia. These currents support an abundance of life that most of us never consider. 94% of all life on Earth is aquatic. While we tend to think of ourselves and the animals we see on land as representing life, we're actually the minority. The real diversity of life is in the ocean, from the tiniest bacteria to the largest animal that has ever existed, the blue whale. The ocean contains most of what we would call living things. We are the unusual ones, the air breathers, the land dwellers. Life is primarily an oceanic phenomenon. In terms of sheer numbers, the biomass in the ocean is staggering. Scientists estimate there are about 3.5 trillion fish in the ocean. That's about 450 fish for every person on Earth. And that's just fish. Add in all the other marine life, from whales to shrimp to jellyfish to microscopic organisms, and the numbers become almost meaningless. The ocean is, quite literally, teeming with life. All of this life, all of this water, averages out to a depth of about 12,100 feet, or just over 2 miles. That means if you were standing on the average ocean floor, you'd have more than 2 miles of water above your head. It's a strange thing to imagine, all that weight, all that darkness. And yet life exists there, adapted to conditions we can barely comprehend. Fish with light-producing organs, squid with eyes the size of dinner plates, creatures that look more alien than anything we've imagined for science fiction. The pressure at these depths is so intense that it would crush a human instantly. Yet many deep-sea creatures have no swim bladders, no air spaces that could be compressed. They are essentially living at the same pressure inside and out. If you were to bring one of these creatures to the surface, it wouldn't explode from internal pressure, but it would die from the lack of pressure it's adapted to. They are creatures of the deep, and only the deep. Down on that ocean floor, in those dark depths, there are phenomena that seem impossible. There are underwater lakes and rivers on the ocean floor. These are formed when seawater seeps through thick layers of salt deposits, dissolving the salt and creating brine that's much denser than regular seawater. This heavy brine settles into depressions on the ocean floor, forming what look like lakes, complete with shorelines. Some even have waves. They're deadly to most marine life, too salty to survive in, yet they exist as strange pockets of even stranger water, water within water. These brine pools can be quite large. Some are several miles long and hundreds of feet deep. Submarines can actually float on the surface of these underwater lakes because the brine is so much denser than regular seawater. It's an eerie sight, captured in footage from deep-sea submersibles, a distinct boundary between regular seawater and the hypersaline brine below, as clear as the surface of a lake on land. Cross that boundary, and you're in a different world entirely. The ocean floor itself is not the flat, featureless plain many people imagine. It has canyons, valleys, plains, and mountains. The Monterey Canyon off the coast of California is deeper than the Grand Canyon. It plunges down over a mile below the ocean floor in some places. These submarine canyons funnel sediment and nutrients from the shallow continental shelf down to the deep sea, creating pathways for life to travel between different ocean zones. Near these canyons in certain areas, methane seeps from the ocean floor, This methane comes from decomposing organic matter buried in the sediment. It bubbles up through the seafloor and in the cold water forms methane hydrate, sometimes called fire ice. It looks like ice, burns like oil, and is found in vast quantities on the ocean floor. Scientists estimate there may be more energy locked in methane hydrate deposits than in all the world's coal, oil, and natural gas combined. It's an energy source we've barely begun to understand or utilize. The ocean also contains forests, though not the kind you might imagine. Kelp forests grow in shallow, temperate waters around the world. Giant kelp can grow up to 2 feet per day, making it one of the fastest-growing organisms on Earth. These underwater forests provide habitat for thousands of species. Sea otters wrap themselves in kelp to keep from drifting away while they sleep. Fish hide among the fronds. The kelp itself reaches toward the light, creating an underwater canopy, not unlike a forest on land. In warmer waters, coral reefs serve a similar function. Often called the rainforests of the sea, coral reefs cover less than 1% of the ocean floor, but support about 25% of all marine species. The reefs themselves are built by tiny animals called coral polyps. Each polyp is no bigger than a pencil eraser, but working together over thousands of years, they build massive structures. The Great Barrier Reef off the coast of Australia is so large it can be seen from space. It's the largest structure ever built by living organisms. These coral polyps have a symbiotic relationship with algae called zooxanthellae. The algae live inside the coral tissue and use photosynthesis to produce food, sharing it with the coral. In return, the coral provides the algae with protection and access to sunlight. It's a partnership millions of years in the making, delicate and essential. When ocean temperatures rise too much, the coral expels the algae in a stress response called bleaching. Without the algae, the coral turns white and, if the stress continues, dies. Coral reefs around the world are bleaching more frequently now, a sign that the ocean is changing. The ocean has always been changing, of course. Sea levels have risen and fallen throughout Earth's history. During the last ice age, about 20,000 years ago, sea levels were about 400 feet lower than they are today. Land that is now underwater was once dry. The North Sea between Britain and continental Europe was once a vast plain where Stone Age people hunted. Now it's covered by water, and fishing boats sometimes dredge up Stone Age tools from the bottom. The ocean takes back what it once gave up. The ocean also contains ice, strange as that sounds. Icebergs break off from glaciers and ice shelves and drift through the ocean. The largest iceberg ever recorded, designated B-15, broke off from Antarctica's Ross Ice Shelf in 2000. It was about 183 miles long and 23 miles wide, roughly the size of Jamaica. It took years for it to break up and melt. These icebergs are fresh water, not salt water, frozen long ago on land and only now returning to the sea. They drift with currents, dangerous to ships, eventually melting and mixing their ancient water with the salt water around them. Only about 10% of an iceberg is visible above water. The rest is hidden below the surface, which is where the phrase "tip of the iceberg" comes from. The RMS Titanic struck an iceberg in 1912 because, in the dark, the crew couldn't see the massive bulk of ice lurking below the waterline. The ocean hides dangers as easily as it hides wonders. The ocean's ice reaches its greatest extent in the polar regions. The Arctic Ocean is the smallest and shallowest of the world's 5 major oceans, but it's covered by sea ice for much of the year. Only about 10% of an iceberg is visible above water. The rest is hidden below the surface, which is where the phrase "tip of the iceberg" comes from. The RMS Titanic struck an iceberg in 1912 because, in the dark, the crew couldn't see the massive bulk of ice lurking below the waterline. The ocean hides dangers as easily as it hides wonders. The ocean's ice reaches its greatest extent in the polar regions. The Arctic Ocean is the smallest and shallowest of the world's 5 major oceans, but it's covered by sea ice for much of the year. This ice forms when seawater freezes, but the salt is expelled during the freezing process, creating freshwater ice floating on salt water. Polar bears, seals, and Arctic foxes depend on this ice for hunting and survival. As the climate warms, this ice is shrinking, and the animals that depend on it are struggling. In the Antarctic, the situation is different. Antarctica is a continent covered by ice, surrounded by ocean. The Southern Ocean encircles Antarctica, and it's the home of the Antarctic Circumpolar Current, the world's largest ocean current. It moves more water than any other current on Earth, driven by the powerful winds that circle Antarctica. These winds and currents keep Antarctica isolated and cold, locked in ice, even as the rest of the planet warms. The Southern Ocean is incredibly rich in life during the summer months. Krill, small shrimp-like creatures, swarm in vast numbers. A single swarm can contain 2 million tons of krill. They feed on phytoplankton, and in turn, they feed everything else: fish, seals, penguins, and whales. The blue whale travels to Antarctic waters every summer, specifically to feast on krill, consuming up to 4 tons of them per day. The entire Antarctic ecosystem revolves around these tiny creatures. Penguins are perhaps the most iconic Antarctic animals. Emperor penguins, the largest of all penguin species, breed during the Antarctic winter, the harshest season on Earth. The males incubate the eggs on their feet, covered by a fold of skin, standing in temperatures that can drop to -40 degrees with winds over 100 miles per hour. They huddle together for warmth, taking turns standing on the outside of the huddle. It's a remarkable display of endurance and cooperation. And all of this happens right at the edge of the ocean, on sea ice that forms each winter. The ocean's influence on climate extends far beyond the polar regions. The ocean absorbs about 93% of the excess heat trapped by greenhouse gases. Without the ocean absorbing this heat, the atmosphere would be much warmer than it is. The ocean acts as a massive heat sink, moderating Earth's temperature and making the planet habitable. But there's a cost to this. As the ocean warms, it expands, contributing to sea level rise, and warm water holds less dissolved oxygen than cold water, which affects marine life throughout the ocean. The ocean also absorbs about 30% of the carbon dioxide we release into the atmosphere. This CO2 dissolves in seawater and forms carbonic acid, making the ocean more acidic. This process, called ocean acidification, is happening faster now than at any time in the last 300 million years. It affects creatures that build shells or skeletons out of calcium carbonate, like corals, mollusks, and some plankton. As the ocean becomes more acidic, it becomes harder for these creatures to build and maintain their structures. It's a quiet crisis happening beneath the waves. Despite these challenges, the ocean remains resilient. It has endured for billions of years, weathered ice ages and warming periods, mass extinctions, and evolutionary explosions. Life in the ocean is tenacious. New species are being discovered regularly. In fact, scientists estimate that 91% of ocean species have yet to be discovered and described. There are creatures out there we've never seen, living in ways we haven't imagined. The ocean still holds mysteries. Some of the strangest creatures live in the deep sea, in what's called the midnight zone. This zone begins at about 3,300 feet below the surface and extends down to the ocean floor. No sunlight penetrates this deep. It's a world of perpetual darkness, cold, and immense pressure. And yet it's home to creatures like the anglerfish, with its bioluminescent lure dangling in front of its mouth to attract prey. The gulper eel, with its enormous mouth that can swallow prey larger than itself. The vampire squid, with webbing between its arms that looks like a dark cape and light-producing organs covering its body. Many deep-sea creatures produce their own light through a process called bioluminescence. Chemical reactions in their bodies produce light, which they use to attract prey, find mates, or confuse predators. About 90% of deep-sea creatures are bioluminescent. In the darkness of the deep ocean, light is not something that comes from above. It comes from the creatures themselves. Little sparks and glows in the darkness, a living constellation in the deep. One of the most famous bioluminescent displays comes from dinoflagellates, microscopic plankton that glow when disturbed. On certain beaches, on certain nights, the water glows with blue light when waves crash or when you walk through the surf. It's called bioluminescent bay, or bioluminescence, and it's caused by millions of these tiny organisms lighting up at once. It's magical, otherworldly, a reminder that the ocean is full of wonders, both large and small. The ocean is also home to some of the oldest living creatures on Earth. Glass sponges in the deep sea can live for thousands of years. One specimen was estimated to be 11,000 years old. It was alive when humans were just beginning to develop agriculture. Greenland sharks, which live in the cold waters of the North Atlantic and Arctic, can live for over 400 years. Scientists have found Greenland sharks that were likely born before Shakespeare wrote his plays. These creatures move slowly through the cold water, growing slowly, living slowly, outlasting empires and civilizations. The ocean remembers. Water has flowed through the ocean for billions of years, evaporating, falling as rain, running back to the sea and rivers, evaporating again. The water you drank this morning might have been in the ocean last year, might have been swallowed by a whale, might have been part of an iceberg, might have rained on a dinosaur. Water cycles through the planet, through all of us, connecting past and present in an endless loop. The ocean's waves are constantly in motion, driven by wind, by the gravitational pull of the moon and sun, by the rotation of the Earth itself. The highest wave ever recorded by scientific instruments was measured at 84 feet during a North Atlantic storm in 2004. But there are stories of rogue waves, waves much larger than that, appearing without warning in otherwise calm seas. These monster waves, sometimes called freak waves, were thought to be myths until satellites began detecting them regularly. They are real, unpredictable, and incredibly dangerous. The ocean keeps some of its wildness even in our modern age. Waves can travel across entire ocean basins. A storm in the Antarctic can generate waves that travel thousands of miles to crash on beaches in California. Surfers watch weather patterns around the world, waiting for distant storms to send waves their way. The energy of those storms, translated into the motion of water, arrives days later as perfect waves. The ocean connects places that seem impossibly far apart. Tides, driven primarily by the moon's gravity, raise and lower sea levels in predictable rhythms. The highest tides in the world occur in the Bay of Fundy in Canada, where the difference between high and low tide can exceed 50 feet. Twice a day, the ocean rushes in, filling the bay, then rushes out again, leaving the sea floor exposed. It's a powerful demonstration of the moon's influence on our planet. Even though the moon is 238,000 miles away, it tugs at the ocean, and the ocean responds. The ocean also contains vast floating ecosystems in its surface waters. The Sargasso Sea in the North Atlantic is defined not by land boundaries, but by ocean currents. It's a region of calm water in the middle of rotating currents, and it accumulates floating sargassum seaweed. This seaweed forms floating mats that provide habitat for fish, crabs, shrimp, and sea turtles. Young sea turtles spend years drifting in the Sargasso Sea, hiding in the seaweed, growing, before they eventually make their way to coastal waters. It's a nursery in the middle of the ocean, a refuge in the open water. Unfortunately, the same currents that accumulate sargassum also accumulate plastic. The Great Pacific Garbage Patch is a collection of marine debris, mostly plastic, concentrated by ocean currents in the North Pacific. It's not a solid island of trash as some people imagine, but rather a diffuse area where plastic bits outnumber marine life. The plastic breaks down into smaller and smaller pieces, but never truly disappears. It's estimated that there are over 5 trillion pieces of plastic in the world's oceans, weighing more than 250,000 tons. The ocean is not just a natural wonder, it's also a mirror reflecting our own actions. Yet, even in the face of pollution and warming, the ocean continues its ancient rhythms. Seasonal migrations continue. Salmon still return to their natal streams after years at sea, navigating thousands of miles of ocean with remarkable precision. Sea turtles still return to the beaches where they hatched to lay their own eggs, sometimes traveling across entire oceans to do so. Gray whales still make their annual migration from Arctic feeding grounds to warm lagoons in Mexico, one of the longest migrations of any mammal. The patterns hold, passed down through generations, written into the very biology of these creatures. The ocean's depths contain mountains we've named, though we've never climbed them. Seamounts, underwater mountains that don't reach the surface, dot the ocean floor. There are tens of thousands of them, perhaps more than 100,000. They rise from the abyssal plains, oases of life in the deep sea. Currents flowing over seamounts bring nutrients up from the depths, creating feeding grounds for fish and marine mammals. Many seamounts are home to ancient cold-water corals, some of which have been growing for thousands of years. The abyssal plains themselves are the flattest places on Earth. These vast underwater plains cover about 40% of the ocean floor. They're formed by sediment slowly settling from the water above, layer upon layer over millions of years. They can be over 3 miles below the surface, dark, cold, and nearly featureless. Yet even here, life exists. Sea cucumbers, brittle stars, and strange fish crawl or swim slowly across the soft sediment, feeding on whatever organic matter drifts down from above. It's a slow-motion world, patient and quiet. In some places, the ocean floor drops away into trenches. There are about 30 of these ocean trenches around the world, most located around the edges of the Pacific Ocean. They form where one tectonic plate is forced beneath another, creating some of the deepest places on Earth. Besides the Mariana Trench, there's the Tonga Trench, the Philippine Trench, the Kermadec Trench, all plunging down over 6 miles. These are the final frontiers, the least explored places on our planet. More people have been to the moon than have been to the bottom of the deepest ocean trench. The ocean contains springs of fresh water, surprisingly. Underwater caves in the seafloor sometimes channel fresh water from land out into the ocean. These springs create pockets of fresher water on the seafloor, mixing slowly with the salt water around them. Some cultures knew about these springs long before modern science documented them. Greek and Roman texts mention sailors filling water jugs from underwater springs off the coast. The ocean is not uniformly salty. It has pockets, layers, streams of different salinity, different temperature, creating complexity within the vast blue. The color blue itself is a property of the ocean worth contemplating. The ocean appears blue because water absorbs colors in the red part of the light spectrum and reflects colors in the blue part. The deeper you go, the more red light is absorbed, until at depth everything appears blue-green or simply dark. But in tropical waters, where the water is clear and the ocean floor is shallow, the water can appear turquoise or aquamarine, colors so vivid they seem artificial. The ocean's color changes with depth, with the amount of phytoplankton, with the angle of the sun, with the seafloor beneath. It's never just one blue. The ocean sounds like a paradox. It can be the quietest place and the loudest place. In the deep sea, away from the surface and away from the noise of civilization, there's a profound quiet. But there's also sound, the clicks of dolphin echolocation, the creaking of ships, the rumble of underwater earthquakes, the groaning of icebergs, the songs of whales, and increasingly, the noise of human activity, ship engines, sonar, underwater construction. The ocean is getting louder, and the creatures that depend on sound are having to adapt. Ships crossing the ocean leave wakes that can last for hours, visible from space. These wakes are lines of disturbed water cutting across the otherwise smooth surface of the sea. Thousands of ships are crossing the ocean at any given moment, carrying cargo from continent to continent. About 90% of global trade is carried by ships. Everything from oil to grain to electronics crosses the ocean in vast container ships, tankers, and bulk carriers. The ocean is not just a natural system, it's a highway, a transportation network that connects the world's economies. Beneath these ships, beneath the paths they travel, the ocean floor is mapped with cables. Undersea cables carry internet traffic and telecommunications signals across oceans. There are hundreds of these cables crisscrossing the ocean floor, connecting continents, making global communication possible. When you send an email from New York to London, it likely travels through a cable lying on the Atlantic seafloor. The ocean is not separate from our modern world, it's integrated into it, essential to it, though we rarely think about it. The ocean has always been a source of food for humans: fish, shellfish, seaweed, sea salt. Coastal communities around the world depend on the ocean for their livelihoods and their sustenance. About 3 billion people worldwide rely on seafood as a primary source of protein. The ocean feeds us, has always fed us, but we're taking more than the ocean can easily replace. Many fish stocks are overfished. Some species, like bluefin tuna, have seen their populations decline by over 90%. The ocean is generous, but it's not infinite. Whaling, once a major industry, nearly drove many whale species to extinction. The blue whale, the largest animal ever to exist, was hunted so intensely that its population dropped to perhaps 1,000 individuals worldwide by the 1960s. An animal that had swum through the oceans for millions of years was nearly wiped out in a few decades. International protections have allowed some whale populations to recover, but slowly. Blue whales now number around 25,000, still just a fraction of their pre-whaling population. The ocean can recover, but it needs time and it needs protection. The ocean also offers solutions to problems we face on land. Medicines derived from marine organisms are being developed to treat cancer, pain, inflammation, and bacterial infections. The cone snail, a predatory sea snail, produces venom that has been developed into a powerful painkiller more effective than morphine. Marine algae are being studied as a source of biofuels. Coral compounds are being investigated for their potential in bone grafts. The ocean is not just something to extract from, it's a library of biological innovation, millions of years of evolution producing chemicals and structures we're only beginning to understand. The study of the ocean, oceanography, is a relatively young science. Systematic exploration of the ocean began in earnest only in the 19th century. The HMS Challenger expedition from 1872 to 1876 traveled nearly 70,000 miles, collecting samples and data from all the world's oceans. It was the first global scientific study of the ocean, and it laid the groundwork for modern oceanography. The expedition discovered thousands of new species and mapped much of the ocean floor for the first time. We've learned an enormous amount since then, but we're still, in many ways, just beginning. Technologies like sonar, first developed for submarine warfare, have allowed us to map the ocean floor in detail. Satellites can measure sea surface temperature, ocean color indicating phytoplankton blooms, and even the height of the sea surface, which reveals underwater mountains and trenches through their gravitational effects. Autonomous underwater vehicles and remotely operated vehicles allow us to explore depths humans can't physically reach. Our understanding of the ocean is growing faster now than at any time in history, and yet 95% remains unexplored. The ocean has moods, if you can call them that. It can be calm as glass, reflecting the sky like a mirror. It can be choppy with whitecaps, playful and energetic. It can be stormy with waves like mountains and winds that shriek. It can be foggy and mysterious, hiding what's just a few feet away. Sailors have always known this, have always respected the ocean's power and unpredictability. The ocean is not a place to take lightly. It demands respect. There are zones in the ocean where oxygen is depleted, called dead zones. These occur naturally in some places, but they're expanding due to pollution, particularly nutrient runoff from agriculture. The nutrients cause algae blooms, and when the algae die and decompose, the decomposition uses up the oxygen in the water. Fish and other marine life can't survive in these low oxygen zones. The Gulf of Mexico has a dead zone that forms every summer, sometimes covering an area the size of New Jersey. It's a reminder that the ocean, vast as it is, can be affected by what we do on land. The ocean also contains chimneys of super hot water called black smokers. These are hydrothermal vents that spew water heated to over 700 degrees Fahrenheit. The water is rich in dissolved minerals, and when it hits the cold ocean water, the minerals precipitate out, forming dark chimney-like structures that can grow several stories tall. The water coming out is black with sulfide minerals, hence the name. Around these black smokers, entire ecosystems exist based not on photosynthesis, but on chemosynthesis, with bacteria converting chemicals from the vent into energy. It's life powered by the Earth itself. Near the surface, in the sunlit zones, life is more familiar but no less remarkable. Schools of fish move together in perfect synchronization, thousands of individuals acting as one. This behavior, called schooling, confuses predators and helps the fish find food and mates. From above, these schools can look like a giant organism, shifting and flowing through the water. It's a beautiful demonstration of cooperation without central control. Each fish follows simple rules based on the movement of its neighbors, and the result is a coordinated dance. Dolphins and porpoises often swim in groups called pods. They're highly intelligent, social animals that communicate with clicks, whistles, and body language. Dolphins have been observed using tools, teaching each other new behaviors, and showing empathy for injured or sick members of their pod. Some dolphins in Shark Bay, Australia, use sea sponges to protect their noses while foraging on the sea floor. They learn this behavior from their mothers and pass it on to their offspring. It's a culture transmitted across generations, showing that humans aren't the only ones with learned traditions. Sharks, often feared, are actually crucial to ocean health. As apex predators, they keep other populations in check. When sharks are removed from an ecosystem, the effects cascade down the food web. Prey species populations explode, they overgraze their food sources, and the whole system can collapse. Shark populations have declined dramatically due to overfishing and shark finning. Some species have decreased by over 90%. The ocean needs its predators. They maintain the balance that keeps the whole system functioning. Manta rays, some of the largest rays in the ocean, with wingspans over 20 feet, filter plankton from the water as they swim. They're gentle giants, often approaching divers with apparent curiosity. Despite their size, they're completely harmless to humans. They glide through the water with an effortless grace, their wing-like fins propelling them forward in a motion that looks more like flying than swimming. The ocean is home to some of the most ancient life forms still in existence. Horseshoe crabs, despite their name, are more closely related to spiders than to crabs. They've existed for over 450 million years, virtually unchanged. They were here before the dinosaurs, survived every mass extinction, and continue to crawl along sandy ocean bottoms today. Their blood is blue due to copper-based hemocyanin instead of iron-based hemoglobin, and it's incredibly valuable to medicine. It's used to test vaccines and medical equipment for bacterial contamination. These ancient creatures, unchanged for 500 million years, are helping us in the modern world. Jellyfish, though they seem fragile and simple, are also ancient. They've been drifting through the ocean for over 500 million years. They have no brain, no heart, no bones. They're 95% water, and yet they survive, even thrive. Some jellyfish are immortal in a sense. The Turritopsis dohrnii, also called the immortal jellyfish, can revert to its juvenile polyp stage after reaching maturity. It can essentially restart its life cycle, potentially living forever unless killed by predation or disease. It's a form of biological immortality that scientists are studying intensely. The ocean has layers, defined by temperature and light. The surface layer, warmed by the sun, is called the epipelagic zone. Below that is the mesopelagic, or twilight zone, where some light penetrates but not enough for photosynthesis. Deeper still is the bathypelagic, or midnight zone, where no light reaches at all. Below that, the abyssopelagic, and finally, the deepest trenches are in the hadopelagic zone. Each zone has its own community of creatures adapted to the conditions there. The ocean is not one place, but many, stacked on top of each other, each with its own character. Ocean water is constantly mixing, but slowly. There are layers of water with different temperatures and salinities that don't easily mix. The thermocline is a layer where temperature changes rapidly with depth. The halocline is where salinity changes rapidly. These layers can trap sound, create boundaries for marine life, and affect how the ocean circulates. The ocean is stratified, layered like a cake, and these layers influence everything from weather patterns to where fish can live. The ocean's saltiness varies by location. The Atlantic Ocean is slightly saltier than the Pacific. The Red Sea and the Mediterranean are very salty because of high evaporation rates and limited freshwater input. The Baltic Sea is only slightly salty because it receives a lot of fresh water from rivers and has limited connection to the saltier Atlantic. These differences in salinity affect ocean currents, marine life, and even how easy it is to float in the water. The Dead Sea, actually a lake, is so salty that you float effortlessly on the surface. The ocean affects weather and climate in profound ways. Hurricanes and typhoons form over warm ocean water. The warm water evaporates, rises, and releases energy as it condenses into clouds. This energy powers the storm. That's why hurricanes weaken when they move over land or cooler water. They're engines driven by the ocean's heat. The most powerful hurricanes form in the western Pacific, where the water is warmest and the ocean is deepest. Typhoon Tip in 1979 had winds of 190 miles per hour and was the largest tropical cyclone ever recorded, with a diameter of over 1,300 miles. El Niño and La Niña are climate patterns caused by changes in ocean temperatures in the Pacific. During El Niño, warm water spreads across the eastern Pacific, affecting weather worldwide. It can cause droughts in some areas and floods in others. La Niña is the opposite pattern, with cooler water in the eastern Pacific, and it has its own global effects. These patterns show how interconnected the ocean and atmosphere are. A change in water temperature on one side of the Pacific can alter rainfall patterns on the other side of the world. The ocean absorbs sound as well as heat and carbon dioxide. Low-frequency sounds like those produced by whales travel farther than high-frequency sounds. This is why whale songs are low and rumbling. But even these can be disrupted by noise pollution. Military sonar used to detect submarines can interfere with whale navigation and communication. There have been instances where whales have beached themselves after exposure to intense sonar. The ocean is not just a visual environment for these creatures, it's an acoustic environment, and we're making it noisier. Coral bleaching, mentioned earlier, is not always fatal. If conditions improve quickly enough, the coral can reabsorb algae and recover. Some corals are more resilient than others, and scientists are working to identify and propagate these hardier varieties. Coral restoration projects are underway around the world, growing coral in nurseries and transplanting them to damaged reefs. It's a slow process, but there's hope. The ocean can heal if we give it the chance. Seagrass meadows, often overlooked, are incredibly important ecosystems. They provide habitat for fish, seahorses, and manatees. They filter water and trap sediment, and they're excellent at capturing and storing carbon, even more efficient per area than rainforests. Seagrass meadows are being lost due to coastal development and pollution, but they're also being restored. Like coral reefs, they're vital to ocean health and to our own well-being. Mangrove forests grow at the boundary between land and sea in brackish water. Their tangled roots provide nursery habitat for many fish species. They protect coastlines from erosion and storm surge. They filter pollutants from runoff before it reaches the ocean. And, like seagrass, they're excellent at storing carbon. Mangroves are among the most productive ecosystems on Earth, and they're being lost at an alarming rate. But again, there are restoration efforts, replanting mangroves, recognizing their value not just ecologically, but economically. The ocean connects all of us, even those of us who live far from the coast. The water we drink, the air we breathe, the climate we live in, all are influenced by the ocean. The ocean is not separate from us. It's part of the system that supports all life on Earth. We are all, in a sense, ocean creatures. Our blood has a similar salt concentration to seawater. Some scientists believe this is an echo of our evolutionary past when our ancestors lived in the sea. We carry the ocean within us. Ancient sailors navigated by the stars, but also by their knowledge of currents, waves, and the behavior of marine life. Polynesian navigators crossed the Pacific Ocean in outrigger canoes, using only their observations and passed down knowledge to find tiny islands in the vastness of the ocean. They read the waves, noting how they reflected off distant land. They watched birds, knowing certain species flew out from land only so far. They felt the currents. It was a deep, intimate knowledge of the ocean, earned over generations. We've lost much of that knowledge in the age of GPS, but it reminds us that the ocean can be known if you pay attention. The ocean has inspired art, literature, music, and mythology for as long as humans have encountered it. From Homer's Odyssey to Moby Dick to The Old Man and the Sea, the ocean has been a setting for stories of adventure, obsession, and struggle. It represents the unknown, the sublime, the power of nature. Sailors' songs and sea shanties captured the rhythm of life at sea. Painters have tried to capture the ocean's many moods, from Turner's violent seascapes to Hokusai's great wave. The ocean speaks to something deep in us, a sense of wonder and respect. Many creation myths involve the ocean. In some traditions, the world emerged from primordial waters. In others, gods or spirits inhabit the sea. The ocean is sacred in many cultures, a source of life and mystery. This reverence is not misplaced. The ocean is, in very real terms, the source of life on Earth. Life began in the ocean billions of years ago, and it continues to support life today. There are bays and seas within the ocean, each with its own character. The Bay of Bengal, the Gulf of Mexico, the Caribbean Sea, the Mediterranean, the North Sea, the Sea of Japan. These are partly enclosed by land, giving them different conditions than the open ocean. They often have unique ecosystems and are heavily used by humans for fishing, shipping, and recreation. They're transitional zones between the vastness of the ocean and the familiarity of land. Tide pools, left behind when the tide goes out, are miniature oceans. They're home to sea stars, anemones, crabs, mussels, barnacles, and small fish. These creatures have to endure dramatic changes in temperature and salinity as the pool heats up in the sun and fresh water from rain dilutes the seawater. They're hardy, adaptable, and a great introduction to ocean life for those who can't venture into deeper water. Children explore tide pools, learning to be gentle with the creatures, learning to observe. It's often where a love of the ocean begins. The ocean at night is a different place. Bioluminescence becomes visible. Certain fish and squid that hide during the day come out to hunt. The ocean's nocturnal shift is as real as any on land. And above the water, if you're far from land, the stars are astonishingly clear. The Milky Way stretches across the sky, and you can understand why ancient peoples saw it as a river in the sky, mirroring the ocean below. There's a symmetry, a connection between the vastness above and the vastness below. During the day, the ocean's surface sparkles in the sunlight. The technical term for this is sunglint. The angle of the sun and the texture of the water create patterns of light that change constantly. It's beautiful, hypnotic. People can watch the ocean for hours, seeing new patterns in the waves, new colors in the water. It's meditative, calming. The ocean has always been a place of contemplation. The ocean is also a place of power. Wave energy, tidal energy, and thermal energy from the ocean's temperature differences are all being explored as renewable energy sources. The ocean is constantly in motion, and that motion is energy. Harnessing even a small fraction of it could provide clean power to coastal communities. The ocean has given us so much already. It continues to offer solutions. People ask if there are undiscovered large animals in the ocean. It's possible. The giant squid, which can grow to over 40 feet long, was a legend until a live one was filmed in 2004. The colossal squid, even larger, was only confirmed to exist in recent decades. There may be other large creatures in the deep ocean that we haven't encountered yet. The ocean is vast, deep, and still largely unexplored. It keeps its secrets. There are also sounds in the ocean that we can't explain. The bloop, recorded in 1997, was an ultra-low frequency sound detected by underwater microphones. It was loud enough to be heard over 3,000 miles away. For years, it was a mystery. Some speculated it was a massive unknown creature. It was eventually determined to be the sound of an ice quake, an iceberg cracking and breaking. But the fact that it took years to identify reminds us how much we don't know about the ocean's soundscape. The ocean is full of such mysteries. Lights seen deep underwater by sailors, never fully explained. Accounts of massive waves appearing without warning. Disappearances of ships and aircraft. Some of these have explanations, others remain unsolved. The ocean does not give up all its answers easily. As we come to the end of our journey through these facts, it's worth remembering that everything we've talked about is still out there. The ocean continues, day and night, summer and winter, through storms and calm. It moves, it breathes, it lives. It's ancient beyond our comprehension, and yet constantly renewing itself. Water evaporates, falls as rain, returns to the sea. Life is born, grows, dies, and is replaced. The cycles continue. The ocean asks nothing of us, except perhaps respect and care. It has given us food, oxygen, climate regulation, beauty, inspiration. It has shaped our planet and our history. It will continue long after we're gone. But what state it will be in depends on us. We have the power to harm the ocean, and we have the power to protect it. The choice is ours. For now, rest in the knowledge of the ocean's presence. Wherever you are, the ocean is there too, covering most of the planet, breathing oxygen into the atmosphere, moderating the climate, supporting life. It connects us to every other person on Earth, to every living thing. We are all part of this blue planet, this ocean world. The waves continue to roll. The currents continue to flow. The creatures of the deep continue their lives in the darkness, and the ocean, patient and eternal, continues its ancient song. As we conclude, let yourself rest with the ocean. Imagine the gentle rise and fall of waves, the slow drift of currents, the quiet of the deep. The ocean has been here for billions of years and will be here for billions more. It's constant, reliable, eternal. Let that constancy comfort you. Let the vastness of the ocean remind you of the vastness of time and space, and let yourself be small for a moment, held safely in that vastness. The ocean continues, and so do you. Rest now. Sleep well.